Okay, so looking at your work, I can see most of you have this answer. So our spherical snowball is melting in such a way that the volume is decreasing at a rate of 1 cubic centimeter per minute. The question is, at what rate is the radius decreasing when the radius is 5 centimeters? Okay, so once again, V is volume and R is radius, and I think those ones are so obvious that I don't really think you need to write them down. The volume for a sphere, 4/3 pi r cubed. And here's what we're given in the question. Here are givens. So the volume is decreasing. That is, the change in volume with respect to time is decreasing. It's negative. It's negative 1 centimeter cubed per minute. I'm asked to find at what rate the radius is decreasing. That is, what's the change in the radius with respect to time? And that's the question I'm trying to answer. When, at this exact moment, so an instantaneous rate of change at the moment the radius is 5. So I'm going to take my formula, volume equals 4/3 pi r cubed, and I'm going to take the derivative with respect to time for both sides. The derivative with respect to time of 4/3 pi r cubed. So dV by dt, I'm going to leave that as my variable. The change in volume with respect to time is equal to, take the constant out in front, 4/3 pi times the derivative of r cubed with respect to time. The derivative of r cubed is 3r squared dr by dt, because I'm differentiating with respect to time. Simplifying this equation, I have dV by dt is equal to 4 pi r squared dr by dt, or dV by dt divided by 4 pi r squared would give me dr by dt. And some people like to set the equation up before they start substituting. And then this is what you're trying to solve for. Substitute in your values. dV by dt is negative 1, and we've got 4 pi times 5 squared, or 4 times 25, negative 1 over 100 pi, or if you wanted it in decimal form, negative 0.00318, and my units, centimeters per minute, is dr by dt. Okay, let's look at setting up number 3. So you've had a chance to read it through and try drawing a picture. So here's the wall, here's the floor, and I've got this 10-foot ladder resting against the wall. And please note that the length of that ladder isn't changing. So then what is happening is that the ladder is sliding away from the wall. The foot of the ladder, the bottom of the ladder slides away from the wall at a rate of 1 foot per second. And of course, if the ladder slides away from the wall, this top of the ladder is going to slide down the wall. Okay, so a little bit later, I have this same 10-foot ladder, and it looks like that. Okay, so I'm just going to put in some variables. I'm going to put an x here, and I'm going to let x equal the distance from the wall to the foot of the ladder. I think sometimes it's tedious to set up a key, but if you stop and do this, you can really clarify what your variables represent. Sometimes when you come back with your interpretation, you misinterpret what you said it was going to be. So really be specific about what your variables are. I'm going to call this y, and I'm going to let y equal the distance from the floor to the top of the ladder. Okay, so if if the ladder is sliding out, then what am I given? I'm given this information. The change in x with respect to time is 1 foot per second. Right? X was measuring a distance. I've got distance over time. What am I asked to find? Well, I'm wondering how fast this top of this ladder is sliding down. I'm looking to find the change in y with respect to time. Okay, that's the question I need to answer. When the ladder is 6 feet from the wall. So at the moment, x is 6. Okay, so we've got a good picture of what's happening. How are we going to solve that? We need to find a relationship between our variables. Can I relate x to y? Sure I can. Pythagoras, right? So we've got x squared plus y squared. What does it equal? 10 squared. Because that hypotenuse doesn't change. Okay, this is a little different setup than the last question, the 2 questions we looked at. So we're going to look at then differentiating with respect to time. Differentiating both sides of the equation with respect to time. So go ahead and do that. Take the derivative of x squared plus y squared implicitly with respect to time. Give it a try. I wish I had a pause button on here. I bet I do.